Hello and welcome to this session of J Champions Conference. Here I have a great pleasure of introducing a fellow Java champion and also fellow GDE Google developer expert, Kito. And a few words about Kito. So Kito Mann is co-host of a Stacked podcast and the author of Java's Server Faces in Action book. He also participated in several Java community process expert groups and is an internationally recognized speaker. So, without any further ado, I'll leave the stage to you to talk about your topic and present also, say maybe a few words about yourself.
Okay.
Stage is yours.
Thank you very much, sir. Appreciate it. Nice to see you again.
Likewise. One more thing I probably should mention actually before giving stage to you is that we'll handle the questions as they come in. So please type them in the chat window, and I'll pick them up and I'll read them for Kito as soon as I can, as soon as the opportunity shows up. So that's the last announcement. So now the stage is yours.
Okay. So, hello and welcome. The session is called GraphQL Distilled. And Rustam said a lot of nice things about me, so I'm not going to say much else. But my name is Kito. And as he mentioned, I'm a Java champion and Google developer expert focusing on web technologies. I'm the co-host of the Stack podcast, which is a great podcast to check out just to hear me and a couple other developers and sometimes guests talk about just enterprise development, back end, front end, Java, JavaScript, TypeScript, all that kind of stuff. So if you're interested in another tech podcast, you should check that out. Um, I also do training, consulting, and mentoring on a variety of technologies, everything from front end stuff with web components and TypeScript to back end development with microservices. And lately, I've been working with AWS a lot as well. So just kind of run the gamut there. Um, Today, though, I want to talk to you about GraphQL, and I did want to ask a question. Rustam, I don't know how we can handle this, but usually I like to get a handle on like how many people are familiar with uh, GraphQL, or how many people have worked with it before.
We
Uh,
can do that in the chat window. So
okay,
there is a just to make just to let you know there is a tiny little delay of like around 5 to 10 seconds
okay,
from what we're saying till it appears. But apart from that, people can just comment in the chat.
okay, cool. So yeah, that's the question. How like has anyone here worked with GraphQL before? And or are you mostly just people who are really interested in it? That's sort of the main question. Just want to kind of get a handle on the audience.
We have a tiny little thing. Could you try to adjust your volume a little bit up? Because
Yeah.
somebody is commenting that it's a bit low.
Okay. Well, I'll just try and speak louder. It's probably the easiest thing to do.
All right.
Is that a
Sounds
little
good.
better?
Thank you. Thank you very much. Yes, it sounds better to me, but
Okay.
let's see what the other ones say.
Okay.
So, do you see the chat window, or do you
I
want me to?
I don't see the chat window.
It's on YouTube, so if you click on the YouTube link, but I can try to do a little summary.
Okay. That might
So,
be useful.
only heard about it a few presentations ago. Looked at the website before, gone through an example. Another third comment would be read basic docs. Another one is I'm a complete beginner at GraphQL. A little bit familiar, just tried it in an example. So yeah, that's the
Okay.
comments that we have received so far.
Okay, cool. All right, now I see the comments too. Okay, cool. All right, so this sounds like you guys are all in the right talk then, which is great. So, all right, so um, I guess we'll start with what exactly is GraphQL. And if you've worked, well, I'll take a step back. I'm assuming everyone here has pretty much worked with, general APIs, basically the idea that you've written some backend code and you need to respond to a front end whether it's a mobile front end or a web app or whatever, and provide some data. And usually we do that with REST. But of course, there's been other ways like SOAP, et cetera, et cetera. GraphQL is basically a different approach. So basically, think of it as a totally another way to handle client-server communication. So on the left here, we have a query, and this is basically saying, give me all the heroes that you have, and also provide, and just give me the name property, okay? And this is the response that comes back. So it gives you one hero and the name property of that hero. And that's the basic idea. You just basically, you can send queries and you can get data back. But of course, there's a little more to it. First of all, it doesn't use REST. So it's not based on REST. It actually is completely different. Also, one of the key tenets is that the client can actually decide what they want back. So if you look at this example, we're asking for all the heroes, but we only want the name property. And this is one of the main benefits, which is that the client can decide what data it wants, which helps with, of course, bandwidth issues, and also makes it easier on the client because they don't have to parse a lot of stuff the client doesn't actually need. All right. So like many things, this was created by Facebook in 2012, and this makes a lot of sense for a company like Facebook because essentially their entire data set is a graph, right? It's a graph of relationships between people and all sorts of different aspects of a person and their relationships to other people, and the whole world of Facebook is essentially a social graph. So it was created by Facebook in 2012. It was open sourced in 2015, and there's actually a foundation that started in 2017. And there's actually a lot of large companies which use it. If you look at this list here, there's probably a lot that you recognize. And even if you look at GitHub, they actually now expose a GraphQL API for all of their repos, as well as a REST API, which is older. But you can see Lyft, Twitter, PayPal, NBC, lots of other companies as well. So, so GraphQL has done pretty well in terms of providing an alternate way for clients and servers to interact. So that's great. But if you're building an application now and REST is working for you, the question is why bother, right? You may not really need to do anything else if REST is working fine for you, and that may be true. But it's worthwhile getting a handle on what scenarios GraphQL works well in. So what are some of the benefits? Well, the first is what I just mentioned before, which is the client decide what data it wants, and the server decides where to get it. So you sort of decouple those things as opposed to saying, okay, let me make a request to this endpoint. This endpoint is going to give me all the properties back of this object or this set of objects. You basically say, I want this data. These are the properties of this data I want, and then the server decides where to get it. So in a simple case, it'll get it all from one database, but it doesn't necessarily have to. And this is really where the power comes in. The GraphQL API can basically expose a representation of data, and that data may be on one or more servers, or it may be across different services, etc. And as a consequence, GraphQL is actually well suited for BFFs, which is basically a backend for front ends. So the idea may be that, let's say you have 10 different microservices that all provide different APIs, but you want to provide one consolidated, consistent API to the front end, and the front end wants to be able to sort of decide what data it wants and what properties it really needs. So in that scenario, you can use GraphQL as your backend for front end. So it basically aggregates data from several other services. That's one common use case. And one of the main differences is that there's a single consolidated dynamic endpoint. So whereas with REST, you're continually defining new endpoints that each endpoint has its own interface essentially. With GraphQL, you basically have one GraphQL endpoint, and it just supports a particular GraphQL schema, which may support X number of queries or X number of types of queries, and also several other features as well.
A quick question that we have received here. How client would know the contract, and also, is there any open API specification documentation for GraphQL?
Okay, so yeah, that's a good question. The contract is defined by a schema. So we'll talk about that in just a couple minutes. And the schema provides all the stuff that you would expect to have in Open API, essentially. So,
All right,
so
thank
there
you.
is a very well-defined contract.
Thank you very much.
You're welcome. Um, so just to sort of add to that, basically what you have is this defined data format, and it's actually a typed schema. So just like OpenAPI has types, so does GraphQL. So essentially, you define a schema. The schema defines a contract between the client and the server. Um, Also, another feature is subscriptions, which is essentially the ability to be notified of changes to data. So you could say, okay, I want to subscribe to heroes, and then every time there's a new hero added, I want to get basically get the information pushed to me. So subscriptions are really powerful because they allow you to essentially have push support on top of all the other features of GraphQL. All right, so So those are the benefits of GraphQL. Now let's look at some of the drawbacks of REST. Um, so with REST, basically, the endpoint decides what data is returned. Basically, there's a very fixed contract. Sometimes you have to make several different calls to get the data back because you have several different endpoints to provide the data that you need. Also, there's no specific data format, right? So of course you can describe your data in OpenAPI, right? But REST in general doesn't care, right? I've worked with clients. I think a lot of us have worked with a code where it's REST, but it returns a string. You know, there's no rule in terms of the way, in terms of the idea of doing REST that requires data is in a particular format. It's just that usually there are certain rules that we follow. Also, when it comes to push, there's no real obvious push solution for REST. It's not really part of REST. You just have to do it in some other way. Those are some of the things that REST does not have. All right, so let's look at a quick demo. All right. So actually, let me go back to my browser here. Excuse me. Okay, so let me increase the font size here. So I'm going to do a quick example with something called the SW API. And if you haven't heard of it, the SW API is the Star Wars API. So there is actually a REST interface that provides all the data about Star Wars, basically all the information you could ever want to know about Star Wars. And that API has actually been ported over to GraphQL. So I'm going to look at a couple basic queries. All right, let me just close this real quick. Okay. So this client, by the way, there's a few different tools that you can use to do GraphQL. This one I like a lot. It's called Altair, but there are other ones. A very popular one is GraphIQL, but Altair I like a lot, and it runs inside of Chrome, which is nice. So you can see on the left here, I have a couple different queries. So again, this is the Star Wars API, right? So I can query for all of the planets in the Star Wars universe. So if I run this query, which is this one up here at the top, I'll make this just a little bit bigger. This is the data I get back. So I get a data attribute, and then I get a list of planets. So I can see the climate, the diameter, all the residents, and you see this matches all of the data that I requested, okay? So I requested this. And also what I can do is I can actually get code completion to tell me what other things I can request. So I can also get the height of the residents. I can get their gender. So if I do that, I get that as well. Okay, so there's Leah. There's Remus Antilles and some other people as well. And these are the people that are on a particular planet. Now, I probably would want the name of the planet too, right? So let me see if I can get that. So this is the planet Alderaan. And then, of course, I can get another planet down here, Yavin 6, or 4, excuse me, etc. So I'm basically querying and I'm saying what data I want back. Now, if we look at what's going on here, it's actually quite straightforward. We'll ignore all those error messages there. All right, so if I make this request, okay, so I'm sending a request payload. You can see that down here. And there's basically a standard format for a graph query request. So there's the operation name, and that's because I've given it a name here, okay? And we're saying it's a query, and we're also talking about variables, which I can get into a minute. And then response is basically just JSON, as you see on the left here. So pretty much what you might expect. Nothing too fancy going on there. Now I can also, as you can see down here, for any of these given properties, I can also provide additional parameters as well. So in this query, I want all of the males that are in the Star Wars universe. So there's Skywalker, and then for each one, I want to also get their films as well. So Skywalker is in those films. There's Darth Vader. He's in those films. There's Owen Lars, etc. Okay. And I can also do the same thing for women. So I can get all the females that are in Star Trek. So there's Leia, etc. I'm Star Wars, excuse me. Don't hate. And etc. etc. Okay. So basically what's happening here is inside of the schema, we've defined basically an object that defines the input, right? And that basically provides query parameters, essentially. So this allows us to essentially sort of filter the records that we're getting back so we don't get a whole bunch of records that we have to filter on the client. So that's sort of a very simple example, or this is some simple examples. There's also some other things you can do. So let's look over here. So here we want to get all of the women from Star Wars, right? But we also want to have a parameter sent in, which with the name that we want to use, okay? And we can do this down here by sending in a variable. So we want to find all the women with whose name contains pad, P-A-D, okay? So that gives us this back. So you can also parameterize the query. This helps when you're building the client code because you may have the query specified and then you just want to provide some additional parameters when you're actually executing the query. And there's some built-in things here. So let's say I put it in a search string, which doesn't work. Okay, so I'm just going to get an empty array back, right? And then let's say I did something like this. I just put in G there. Okay, so basically I'm getting this error message back, and this is not something the backend has to actually code. This is part of the GraphQL sort of layer. So the backend, so the GraphQL layer is going to say, okay, well that's not really part of the schema. So I can't fulfill this query, essentially. So you get that kind of stuff for free as well. So another thing that GraphQL supports are directives. So in this scenario, I basically only want to have films included in my results if this include films variable is true. Okay. So basically I have two variables. One is name search string, one is include films. Okay. And right now I'm getting the films back, but if I change this to false, I don't have that included. And also, by the same token, because these variables are typed, you can see that include films is a Boolean, right? If I put this in here, actually the client is going to complain. But if the client actually sent in the data in the wrong type, we would get an error message back as well. But any good client library is going to complain about that because it'll know the actual type that's expected. All right, so there's one more thing I want to show. So far we've been talking about queries. We've been looking at, basically the idea of querying different parts of data, right? And actually, there's two things. So when it comes to queries, we looked at some basic ones, but you also can combine queries as well. So in this example, I have one query, but I'm actually have multiple data sets I'm requesting. So here I can get back multiple things. So there's data, and the first data element is planets, and the second one is films. Okay. So I can even combine multiple queries at once and get them all back in one result, as opposed to making multiple individual REST calls. It's another powerful feature. So in addition to querying for data with GraphQL, you can also change data. You can update. So you can do mutations. So this is an example of a mutation. And basically, we're saying create planet. We're passing in a variable. Okay. So we wanted to create a planet, and we can change this to J champion. All right. So we can change the name there, right? And then we can create our own new planet. So let's see if we do this, what happens. And this tells us what properties we want to get back from the response when we try creating it. Oh, doesn't work, right? So basically, since this is a public API that's exposed, it actually is the backend of this is a tool called GraphCMS, which is a GraphQL-based CMS, and they have basically gone through the trouble of porting this Star Wars API. So of course they're not going to let random people add to their server. I mean, add to their backend, add to the data set. So we're not authorized, but this also gives you an idea of how GraphQL handles errors. So this is essentially a default error coming back from GraphQL. The backend said the error was not authorized, but the format and everything is a default piece of GraphQL. So you can even return errors if and data at the same time. So if, for example, you were talking to 4 different microservices and there was one part of the data which you couldn't return, you can return an error message for that part and then still return the rest of the data as well. So there's a lot of flexibility, and there's also obviously a standard way to return errors as well. So that's sort of a quick overview of queries and mutations and look at how GraphQL works in general. I'm going to talk about a couple more things. And the first thing is schemas. So we talked earlier about how schemas allow you to define the contract between the front end and the back end. And as you saw a little bit of, that contract is essentially type safe, right? So you can't put arbitrary types that are not defined by the schema. Also, the client can only request data that's defined in the schema, so you can't add additional properties that are not defined. And what's interesting is while with REST APIs, we usually do versioning by having maybe a different path name. So we have like, v1 / whatever. And then if we have a new version, we have v2 / whatever, or something like that. With GraphQL, you handle it through deprecation, the same way you do with Java code or any language where deprecation is supported. Now, the benefit there is that you don't have to worry about managing all these different versions. The drawback is that you have to actually purge the deprecated fields at some point and make sure the clients actually stop using them. So I think there's a little bit of extra effort involved in that management, but it is very nice to just be able to deprecate something as well. So let's take a look at the GraphQL schemas. So the first thing you get from a schema is the ability for the tool and the client to understand what the contract is. And any good GraphQL tool is going to support the ability to look at the documentation, just like you may be used to with Swagger or OpenAPI. So this is all generated from the schema. So you see here, I have all the properties, all the different entities, that I can request. So you can see I can look for people, films, vehicles, species, starships, etc. Okay, and also tells me details about what the query parameters are. So if I want a planet, I need to send in the name of the planet this way, or I can just get all the planets back as well. So if I look for planet, okay, so there's the planet type, there's the planet field, etc., etc. And here's planets. There we go. All right. So this is essentially one of the queries I did before where I basically said planets, asked for planets, but I didn't have to do where, but I can. And also this supports other features like order by, skip, etc. as well. So the schema, not only does it allow me to get the documentation, but it also gives me the code completion as well. So go ahead.
A little question
Yep.
related, I think, a little bit to that, but mostly to what you said previously. So the one of them is how the data is stored on the server side. So how do you put that thing into? I mean, what's on the other side of the endpoint?
Right. That's a very good question, and we'll get to that in a minute.
Oh,
But
perfect.
the GraphQL doesn't care about like it doesn't care where the data is stored. That's really up to you. So, but we will talk about how you actually implement it on the server in a few minutes.
All right. That's fantastic. Thank you. And the other question was on authentication. So can we use all the REST-based authentication with GraphQL as well, like HTTP Basic, Digest, Wealth, 599, and so on?
So the answer is yes. GraphQL doesn't have anything special about authorization built into it at all. And at the end of the day, you still are making HTTP requests. So all that's still supported. You just have to make sure it works with whatever framework you're using on the server to implement GraphQL. So
Awesome. Fantastic. Thank you very much.
you're welcome. So I just wanted to go back to the code completion there. Of course, actually, this is not the right one. We'll try a different request. All right, so yeah, so here we've got that code completion, and again, all this comes from the schema. Now, one of the nice things here is, the schema is, again, a document, right? And you can actually export it from a tool like this, or of course, if your backend can generate it, you can also build the schema separately, which we'll talk about in a minute. So this is an example of a schema, okay? So let me make it a little bit bigger here. Okay, so this is actually the schema that I just showed you. And you see it's got a lot of stuff in here, okay? But you can actually, it actually makes a lot of sense when you look at it. So for example, here's a film, okay? So a film is an actual type. And you can see we have different properties which are defined, okay? And you can see that there are also interfaces. So a film implements node, and node is basically just an object with an ID, okay? You can also have comments, and this is what shows up in the tools when they're actually displaying the docs. And you can see there's some basic types. And you can also, of course, obviously make your own types. So all the vehicles here, they take as parameters these different values, which are optional. And then they return the vehicle type, which has all of these properties. Okay. So basically, the schema defines exactly what is allowed to be sent back and forth, what properties are available, which ones can be null. That's what this exclamation point is. Okay. And all the different objects involved. There's also enums, as you see here. So gamma status. And these input objects are special types that are used just for input. So and these are, in this particular schema, these are used mostly for, query parameters. So this is an example of schema. And as you can see, this one's pretty complicated, but they don't all have to be. You could, of course, build a much simpler schema depending on your data model as well. So, and here's the query type. This basically defines all the different queries that are allowed. Okay. So we've got assets, species, etc. You saw all these before when we were looking at the docs. And if we look at the mutation type, got the same things. This defines all the different updates that can be made. So you can create basically everything and update everything. And whether or not you need mutations really depends on what you're building. There may be some APIs that are just read-only. It just really depends on what you're building. So that's an example of what a schema looks like. Now, when it comes to actually building a schema, you have a few choices. go to the right window here. So there's basically a couple options. You can do what's called schema first development, where you essentially build a document like the one I just showed you. And then you use that as the contract between the front end and the back end. Okay. So what that means is that there's interesting things you can do along the lines of code generation, right? So you can basically develop a schema. You can actually generate JavaScript or TypeScript code or other languages from the front end. I mean, from the schema itself. Okay. And you can also generate classes on the back end as well. You can generate Java classes. So I worked on a project where we actually did this. We did the schema first approach. We built the schema with the front end and the back end together. We generated TypeScript code and we generated Java code. And that allowed us to basically have a very tight contract between the front end and the back end. So this works well in situations where you have basically a front end team that you need to collaborate with that actually wants to be involved with the process, where you want to use code generation, and where the extra overhead of maintaining maybe another repo or something makes sense. Yes.
I'll just jump in right now because it's a related question again. It looks like backend is in Scala. Can we use Java?
Actually, are you talking about the schema that I just showed is actually the GraphQL schema format? So it wasn't Java or Scala. It was just
okay.
that's actually what the schema looks like. But you can use any language you want basically, and we'll get into that in a minute. And definitely you can use Java. So,
fantastic. Thanks again.
You're welcome. So the code first approach is where you basically use the backend to drive the schema. So, and this works well in situations where the backend knows really well what's going on. Maybe you don't even have a front end yet, right? And in that scenario, you can just basically write code in the backend, have the backend generate the schema dynamically, and then the front end can consume it that way. And the key thing is just that you have to make the decision up front. So you have to, you can't sort of halfway do it one way and the other way. You kind of have to decide up front and then make sure all the stakeholders are involved and working the same way together. So just keep that in mind. All right, so let's get into one more key detail, then we get into some specifics. So another feature is the ability to do subscriptions. And I mentioned before that this is the idea where you can push changes back to the client, right? And this works really well in scenarios where you essentially need to have real-time updates. So for example, the project I was on where we were using GraphQL, we had a client, it was a web application, and the web app, at first when we wrote it, we decided to use GraphQL because it was just basically doing a lot of queries for data. And eventually we had a requirement where we needed to push data out to multiple front ends so that, if like there were 4 or 5 people looking at something, they would all get changes simultaneously without having to refresh automatically. And subscriptions worked out really well for that because we were able to push those changes out to every single subscriber, every single web app that was using our backend at the same time. So that's one of the greatest features of GraphQL, in my opinion. And what's nice about it is the way it's implemented, it's not specific to a particular transport protocol. However, when you start looking into it, you find pretty much everything is built on top of a WebSocket. So there are additional, headaches with WebSockets sometimes, especially if you have a more of a secure environment, but it's a pretty powerful feature. I don't have a good demo for this, but I will show you what that looks like. So if I go to subscriptions here, okay, this is one of the ones I looked at before. So basically, it's just like what all the other queries, except you say subscription, and then you specify the properties that you want to get back. And then when those change, you basically get the data pushed back to you. So that's sort of how it works. All right, so that's subscriptions. Now, when it comes to actually using this stuff, which of course is what everyone's interested in, the question is, how do you do it? And it turns out it's actually pretty easy no matter what language you're using. So there is a site called graphql.org which I encourage you to take a look at. And if you see the language support is pretty extensive. So there's basically any language you can think of, there is some sort of support. And on the JavaScript side, there's GraphQL JS, Apollo, etc. And what you'll find is a lot of people just end up using Apollo, which is a really popular client as well. There's also server-side stuff for JavaScript as well. So Apollo client is probably the most popular one I've seen. On the Java side, there's also Kotlin support. And the main product or main project I've seen is GraphQL Java, which is sort of the heavyweight out there. And what I've basically found is that any library you use uses GraphQL Java internally, even if it has some other stuff on top of it. So GraphQL Java is essentially the sort of the core engine. It just has servlets, and usually if you want some more power, it might use GraphQL Java internally. It's also a Kotlin implementation, and that's pretty much it. However, in the world of Java, there's a couple other choices, right? So one of the ones which I'll show in a minute is GraphQL, is microprofile GraphQL. So microprofile GraphQL is basically an implementation of GraphQL running on top of the microprofile, which is basically a specification for microservices that's supported by different vendors like Oracle and Red Hat / IBM and Tommy Tribe and Pyara. And they've got really nice support with microprofile GraphQL. Another option is GraphQL Java Tools. I'll jump over there for a second. So GraphQL Java Tools basically lets you do GraphQL, but gives you the ability to do schema first development. So if I go to docs here, okay. You basically can create a parser, you can actually load a schema, and then you can build classes that use that schema, okay? And GraphQL Java makes it really easy to, if you are doing the schema first approach, to do it that way, which I really like. So this is an example of resolver, which is basically responding to a query. Basically, you could use this as basically a way to return back books, essentially. You also, as we saw earlier, can actually use an actual real schema if you're doing a schema first approach. The other thing about this project, GraphQL Java's Kickstart, is you see that they have Spring Boot integration as well. So if you're using Spring Boot, GraphQL Quick Start is essentially the best way to get started. There are also nice little starter apps you can work with as well. All right. Okay, so let's look at a quick demo. So we'll look at.
Before you do that, I mean, while you do that, I would like to ask another question that came in now. So how the validation works for a new insert, like required field, date format, etc. Is that part of schema as well?
Yes, so exactly. So whether a field is required, the type, all that kind of stuff, that is part of the schema.
Fantastic. Thanks again.
All right. So this project, this is not an example I built. This is an example that is by someone from Red Hat, whose name I will tell you. I believe it's down here. Should give him credit where credit is due. All right. Yes, I will tell you his name when I find it again. But anyways, so essentially what we have here is a normal app. Okay, we're going to actually be doing this via Quarkus. Okay, Quarkus is a microprofile implementation that also has very good support for GraalVM if you want like a fast native runtime. It's from Red Hat / IBM, and basically you can get all the support for GraphQL by just including this Quarkus small ri GraphQL dependency. And I believe I do have it running. Let's see if it's still running. Okay, yep, so it's running here. So I'm just gonna look at it here and you'll see what the interface is. I can find it. Yeah, there we go. Okay. So if I look at the docs for this, I can get people back, and I can get a random number back, and a person with a surname. Okay. So it's a much simpler API. So if I want, I can get this random number back. Okay. And there's my data. And I can also query for people. So, oh, I got an error. Let's see. It says data fetching exception, illegal argument. All right. So let's go back to the code here. And you see there's an exception. So this is an example of how GraphQL is basically providing a standard format for how the client can see the exception. So it says type specified for type query is incompatible with query return type, which is person. All right. So let's make sure that there isn't an error in my query itself. All right. So let's see if I just get back people. Just keep it simple. Okay, so it looks like there may still be something wrong. Let's see if there's something in my code. So what I can do is you see there's the dependency here. Now, macro profile, like most frameworks, uses dependency injection for everything, right? So if I want to find the primary class that handles this work, yes, Philip Kruger. That's the guy who wrote this. so I will give great credit to Philip for coming up with a nice demo for us. So this is actually open source. There are links in my presentation, which I will make available. So basically, this particular app has a RESTful endpoint, but of course has a GraphQL endpoint. And basically, it has a model, which is defined, right? So here's a person, okay? And you see these are normal JPA entities or annotations, okay? So there's a model that's defined here. Nothing too special about it. And then is of course the API, okay? So the API is just a POJO. It has this GraphQL API annotation. You can, of course, inject the services that it uses, and then you can just specify queries, okay? So this query here means it's a GraphQL query, and these are annotations for metrics. So these are not related to GraphQL. It's just part of general macro profile stuff. But basically, we have one particular query, which is get person. So if you send in an ID, we also have get people as well. And then there is scores. So scores actually comes from a completely different location. But because we have this source annotation, it's allowed to be sort of a property of person. So you can't really tell that from the person, that the client can't tell that it's actually coming from a totally different location. So source would allow you to basically say, okay, I am projecting essentially a view of the data, but it's coming from disparate sources, different services. You know, so maybe one may be talking to a database, one may be talking to another microservice, et cetera, et cetera. And here's that simple query get random number. Okay. So if we go back to my example here, all right. So we know that there should be the ability to run a query against people, right? Um, and actually what I wanted to do is just restart this real quick here. It's quite likely that quite possible I broke something here. So.
While you're building that, I think I'll try to squeeze in another question.
Sure.
So whether GraphQL can be integrated with existing database, MySQL, Oracle, or similar, or it's only supported for a new data structure?
Okay, so the answer is that it can support any database you want. So if you look at what's happening here, when someone makes a query, and let's see if we can get I'll try very quickly, see if the people query works now. Okay, yeah, I thought I'd broken something. Okay, all right, so you see this people query is returning back all of this data here, right? Different people and their properties. And we also see it's returning scores, okay? So basically, all that's happening is when you ask for people, we're calling person service.getPeople, okay? Person service can be whatever kind of code you want. It can do whatever you want it to do. So person service here calls the entity manager, which is again JPA, and calls find, right? But this could talk to MySQL, it could talk to any database you want, it could talk to another service, it could be hard coded, it could read it from a text file. It doesn't matter. So think of GraphQL as essentially just a way to transmit data back and forth. It doesn't care about authentication. It doesn't care about where you get the data. As long as you provide it in the right interface, it's fine. Okay. So here we're getting the person. Here where we ask for scores, if you look at a person, it doesn't have a score, right? There's no score property here. So basically, this ability to sort of use this source annotation allows us to get the scores from somewhere else, and you see it passes in a person. So this score service could talk to some completely other database or some other microservice, and basically it's basically doing a join essentially, right? So it's saying, okay, given an ID, let me get all of the scores for that particular user.
I got a follow-up comment slash question on what you said just now. So since it supports any database, isn't it redundant in specifying the schema type definition for the GraphQL as well?
That's a good point. It is if you have a database, it can be redundant. There's a couple points though. You may not want to expose it exactly the same way it is in the database. And also there are tools which will basically just sit in front of your database and give you a GraphQL interface on top of it. So you can kind of go, if you're using Java, you might want to have your own model, which may not exactly map to the database, or you may be aggregating data from multiple databases, in which case you're going to have your own domain model. But if you're just really trying to do a direct query, you could just look for a tool that provides a GraphQL interface to your database, and then you don't have to write any code really. Yeah. So it basically is another way to do the interface.
That's a very good point. Thank you.
You're welcome. All right, so let me see, was there anything else I wanted to show with this example? Okay, yeah, so this is another query. So this is the query for the person with a certain ID. Okay, so remember we talked about mutations. So this is a mutation. So I can create a person. Okay, so I'm going to create myself here. All right, and I basically add myself to the database, and then if I want, I can query it to get myself back. Okay, so there I am. So the way the mutation works is pretty much the same way as the queries. So if I go back to the API and I find this right here, see, it's a mutation. It's update person, and basically it just calls person service and passes in the person. So it's pretty much the same idea. And this calls hibernate or JPA to do the update. I actually wanted to point out one thing. If you look at the way the score service is implemented, it's actually using an in-memory database. And actually, if you look at what it's doing, it has this list, um, a map essentially, and it reads everything from a JSON file. So they basically, this example even shows you that you have basically two completely different data sources. One is just a JSON file, and one is actually JPA. So, so that's the story there. Now, if I, again, if I do something different here, let's say I put in property which doesn't exist, and then I try and send my mutation. Okay, I'm going to get a validation error, type field undefined, field profile picked, and type person is undefined. Okay, and so this is coming from the GraphQL engine. It's not something you have to code yourself. Basically, it knows that it's the wrong type, that it's not supposed to be there. By the same token, if I go up here and I say foobar as a property, I got another error as well, saying that this is undefined. Okay. All right, so that's pretty much an idea of how GraphQL works in a server. It's pretty much going to be somewhat similar regardless of what API you use. Some of them are a little bit easier to use than others. So for example, if you use the GraphQL Kickstart with Spring Boot, it's going to look sort of like this. If you use GraphQL Java by itself, it's going to be more low level. It's a little more complicated to work with. Also, the microprofile GraphQL is really great. It's really easy to use, but it's not quite as powerful as like GraphQL Kickstart in terms of the features. It doesn't support subscriptions. GraphQL Kickstart supports subscriptions. It takes a little bit of work, but it's supported. And there's a few other things you can't do. There's no like context object if you need to send in some more information, things like that. But it's really great for common use cases. All right, so go back over here. There's one more thing I did want to show on the coding side. So we looked at the back end. On the front end, it's also really simple. This is a React. This is not talking to the same back end, but it'll just give you an idea. So this is a search component. And when you click on the search component, it calls execute search, right? Execute search pretty much just make this okay. Just basically awaits calling the GraphQL client. This is using Apollo, passes in the query and the variables, and then it gets the result back. And then it sets it as the internal state of the component. And the query, it looks like this, just a normal GraphQL query. Okay. And you see there's this DQL, which is a templated literal. I forgot the proper term for this. Tagged template literal, yes. So basically, this is a special function that's processing this particular query, but that's part of the Apollo API. Essentially, it's also very straightforward to use on the front end as well. So just wanted to show that. All right. And as I mentioned before, there's lots of different tools. These are just some examples that you can get off the GraphQL org site. There's code generations tools. There's a GraphQL CLI, which I wasn't really mature when I was on that project, but that might be something to look at as well. And there's also integration with Angular. And as I mentioned, Apollo is sort of the main tool that a lot of libraries use. So lots of stuff out there. With databases, I mentioned you can find databases that support GraphQL. So these are some that are known. And of course, anything that's like a graph database or an object-based database is very likely to have a GraphQL interface. So Neo4j is a good example of that. All right, so that's sort of the quick overview. I've talked about all the wonderful things about GraphQL. Next question is why wouldn't you use it, right? So one of the drawbacks, what are the drawbacks? So one is that, sort of the benefits are the drawbacks, right? It has a type schema, it has a defined data format. There's additional overhead involved, and that overhead can be just more libraries or just in the fact of maintaining a schema. And the client has to know what data it wants. So you kind of have to have the client know about the schema. Of course, the client can discover the schema dynamically. That's not a problem. But there is coupling between the client and server, right? So in some cases, this might be too much overhead. Um, Also, if you've got just basically a very simple endpoint and you're not returning a lot of data, there's really no great reason to use GraphQL. GraphQL is really great when you have a lot of data you want to get back and you want to give the control to the client in terms of what they want to get back. So another drawback is that it's not REST, right? So if you have a lot of people that know REST and you don't have a lot of time for them to learn something new, obviously REST might seem like an easier choice. Another thing is that there's more magic. So I know a lot of us get sick of having frameworks to do too much stuff. And this is another framework that's going to do certain things. And there may be errors in the framework, or there may be exceptions that get thrown. We have to dig through and figure out what's going on. So a lot of the stuff you saw where it does validation and things like that, where it has a standard way to return errors, all that stuff is essentially extra framework stuff going on. So for example, in the project I was on, I had to do a lot of sort of digging into the internal extension points in the framework in order to add things like metrics and things like that. Because I wanted metrics not at the service level, but more at the GraphQL level. So there are things like that you have to do or have to keep in mind. All right, and don't forget that REST has benefits, right? It's very easy to get started, right? If you just want to get moving, REST is usually a little bit easier to get started with. If you've got read-only or low data APIs, it's a very good idea. And read-only isn't necessarily that important, but if you don't have a lot of data, REST is great. And obviously, there's no specific data format required. So REST works very well in those situations. All right, so here's some resources. I'm not sure where we're putting up presentations, but I'll try and figure that out so I can post this. But essentially, here's some links. There's the GraphQL site, graphql.org. There's some great articles on different approaches. So if you want to get a handle on whether you want to do schema first or not, there's a couple of great articles out there. You can also find the Star Wars API for Graph CMS, which is what I was using in the demos. Altair, again, is a great GraphQL client. There's a great tutorial out there called How to GraphQL, which is very well written, great sort of step-by-step approach. Here's a link to the example that I did in the demo from Phil Kruger. And also there's a React Apollo example too. So these are a lot of resources. And of course, the internet is full of lots of great information about it. So. All right, that's about.
It's 5 o'clock.
There's my timer. All right, so that's about all I had.
There were a few questions. One of them was that you probably already mentioned, but so there was the question about the GitHub, if there is any place where you can get hold of the code that you've demoed today.
Yeah, so that is actually right here. So if it's Philip-Kruger/GraphQL, if you just basically search for GraphQL example, you'll find it.
Philip has quite a few good resources on that.
Yeah, he does.
I can just mention that on
yes, he does.
personal experience.
Well, and just so you guys know, Philip is involved with microprofile GraphQL for Red Hat, so he's very he's got some good stuff out there.
That's really cool. He also have a few talks, I think, about that as well.
Yes, he does. Yes, he does this supersonic subatomic GraphQL talk a lot. I see this all the time. So, but yeah, so it's a great resource, and this example is good. It runs on Quarkus and Wildfly as well. So
that's really cool. So there was another one last question so far. So unless you folks are asking more questions. This is the last one, at least the one that's been asked so far. Can you query all the data without knowing the schema? So something like select star from blah blah in a relational database.
No, you cannot. So
No.
you have to basically know the schema. You have to know like what sort of the top level queries are, um, and you also need to know what properties you can expect back. Um, so for example, if you did this and you can only do the queries that are supported, right?
Mm.
And then even if if you did this, if you wanted all the people, you have to specify individual properties. You can't do like
Mm.
star to get all the people. That won't work.
But I guess is there a way of maybe that will help? I mean, is there a way of like exploring data, so more kind of explorative approach, kind of?
Well, what you can do is you can look at the schema and then determine what properties from
Right,
there, right?
right.
So if you're looking at the schema and
Mm.
any client-side API would let you do that, you can find out exactly what properties are there. So
Yeah, that
do
makes
it that
sense.
way.
So another comment was about your presentation and the tool you used, MindMeister, I think.
Yes, yes, it's MindMeister.
It's lots of credits to that. So it's really
Thank
like
you.
the presentation with MindMeister. That was the comment. And
Yeah. So
yeah,
just to riff on that for a second. So you can this is the entire presentation, um, and you can basically turn it into a slideshow from the presentation. So
that's really cool.
that's basically how it works.
And the same person asks another question. So, how about the migration of an existing web app from REST to GraphQL? Is there like any good ways of doing that? Because he says that we have a web app with about 50 REST services and it works quite well.
Hmm.
So I guess how that would be to migrate it to REST to GraphQL. So.
Well, I mean, I generally look at things in terms of whether or not they're necessary. So if there was a particular requirement where GraphQL seemed like an obvious win, um, you could do it that way.
Yeah.
You could also do something where if you have whatever requirement, whatever feature you're trying to build, you build that out using GraphQL and maybe have that talk to some of your services directly. So another area where I've seen this used is one of my clients. They were migrating from one front end to a different one. Um,
Mhm.
so in that front end talked to lots of microservices. So what they did was they created a BFF using GraphQL in the front. I think it's in GraphQL. Definitely a BFF.
Mhm.
And then had changed the old front end to talk to that BFF so that when they swap to the new front end, they have a new standard API that they can
Mhm.
use. So you can look at it that way, like maybe incrementally replacing or providing a different, an alternate interface to set up the microservices.
Yeah, that makes sense a lot. And also this the good old if it ain't broke kind of thing as well, I guess.
Exactly, exactly,
Yeah.
exactly.
So that's fantastic. So this is seems to be the last questions.
Okay.
So unless there is nothing, somebody is typing like with light speed and presses enter very soon. I think this will be it, and I will thank you very much for a great presentation and thank you everyone listening first for joining in, but also for asking great questions.
Yeah, thank you
That's
very
been
much.
really great facilitating this talk. So thank you.
Awesome. Well, thanks a lot for being my host, Ristam. Appreciate it.
That's my pleasure.
And thanks everyone for joining.
Bye bye.
Bye bye.